In this video, we are going to be talking about the graphs of cosecant and secant, and then also applying some transformations to those two trig functions. Here we are taking a look at cosecant. Now, cosecant is the reciprocal of sine, and that is what you see in black. The cosecant function is actually graphed in blue and has those vertical asymptotes that are highlighted in orange. Now, when you're looking at this picture, you will notice that the period of cosecant happens to be every 2 pi. That's when it will start to repeat itself again. When you're looking at those vertical asymptotes that are highlighted in orange in this picture, you'll notice that they occur at every multiple of pi. The domain then is very similar because we have to apply those vertical asymptotes to our domain because those are x values that will not work. So our domain happens to be all numbers except multiples of pi. Now the range is very unique in regards to cosecant because you can see that the blue graph doesn't cross horizontal lines of y equals 1 and y equals negative 1. So our range is all values, or all y values specifically, greater than or equal to 1, and y values that are less than or equal to negative 1. Now, the reason for those horizontal asymptotes is because of the fact that if we take a look specifically at the point pi, that is the point negative 1, 0. Now, cosecant happens to be the reciprocal of sine, which is the y value. So we're looking at 1 over that y value, which is 1 over 0, which is undefined. And that is why we have those vertical asymptotes. Taking a look at secant now, secant is the reciprocal of cosine. So the cosine graph is shown to you in black, and the secant graph is shown to you in blue. Again, we have vertical asymptotes with secant. However, it takes 2 pi before secant starts to repeat itself. We have vertical asymptotes occurring at every odd multiple of pi over 2. So what I mean by every odd multiple of pi over 2 is pi over 2, 3 pi over 2, 5 pi over 2, and so on. We discussed those in yesterday's class where we talked about cotangent and tangent. When we're talking about the domain, again, we have to consider those vertical asymptotes occurring for secant. So it's going to be very similar to our vertical asymptotes, but we're going to say all numbers excluding the odd multiples of pi over 2. Now the range, again, you can kind of see the horizontal asymptotes again occurring here at y equals 1 and y equals negative 1. The blue graphs don't go below that. So our range would be y is greater than or equal to 1 and y is less than or equal to negative 1. Very similar to the range for cosecant. Again, the reason why is, let's say we take a look at the point pi over 2, where we have a vertical asymptote. The point for pi over 2 is 0, 1, and secant is the reciprocal of cosine, and cosine happens to be the x value. So when we take the reciprocal of 0, that ends up being 1 over 0, and that is a value that is undefined, and therefore that is why we have a vertical asymptote occurring at those odd multiples of pi over 2. So let's move into some transformations of cosecant and secant. Now, to graph cosecant and secant, you're going to want to make sure that you pay attention to the vertical asymptotes and where they occur for each one of these trig functions, because the process is going to be very similar in regards to graphing tangent and cotangent. So the first thing that we're going to do is we're going to take what is in parentheses and set that equal to each one of our vertical asymptotes for cosecant. So cosecant has vertical asymptotes at negative pi, 0, and positive pi. Okay, so what I did is I took each one of those parentheses, that 2x that's in parentheses, and set it equal to my 3 vertical asymptotes. Now, where do you divide to get x by itself? So you're going to divide each one of those by 2. You're going to notice that you're going to have vertical asymptotes occurring, there we go, at the following 3 locations. The first vertical asymptote is going to be occurring at negative pi over 2. The second one is going to be occurring at 0. And the third one is going to be occurring at positive pi over 2. Okay? Now, the reason why cosecant and secant both had a horizontal asymptote at 1 and negative 1 is because that is where the amplitude was for the paragraphs. So this time, I'm actually going to have a little horizontal asymptote occurring at positive 2 and negative 2. So therefore, I now have my graph set up, and I know for a fact that my graph is not going to go through this area right here. So it won't touch that. So the next thing that you're going to want to do is find the halfway point between negative pi over 2 and 0. And hopefully you can recognize that as being negative pi over 4. And again, finding halfway between 0 and pi over 2. And that's going to be at positive pi over 4. The reason why is because that is where our cosecant graphs are going to start. So the one on the right is going to go up, and the one on the left is going to go down. And there's your graph of cosecant. So again, here's another graph of cosecant, but this time we have a phase shift. So we are going to take what is equal to, what is inside of our parentheses and set it equal to negative pi, 0, and positive pi, and solve for x. So that is what I did here. I took what was inside my parentheses. So you can see here that I set what was in parentheses to negative pi, 0, and positive pi. Now, what I'm going to have to do is subtract pi over 4 from each one of these because I'm shifting my vertical asymptotes to the left pi over 4 units, and I'm working on trying to figure out now where are my new vertical asymptotes going to occur. So you can see here that I subtracted pi over 4 from each one of these, and I had to have common denominators. So I turned all of my pi's, even my negative pi's, to being 4 pi over 4, so that way it was making it easier to find my vertical asymptotes. Now I'm going to go ahead and graph those. So I have 2 vertical asymptotes in the negative region. So here's one at, I should have made that dotted. At negative 5 pi over 4. Here's another one at negative pi over 4. And then my other one is going to be at 3 pi over 4. I'm going to go ahead and label my vertical asymptotes. And now my amplitude for cosecant is 1. So I'm just going to draw a dotted line again to show my horizontal asymptotes occurring at 1 and negative 1. And I'm going to go ahead and label those as well. So remember that cosecant does not go through this shaded region. So the next part of my graph is to find my halfway point. So what ends up being halfway between negative pi over 4 and 3 pi over 4? Well, that ends up being at a positive pi over 4. So I'm going to go ahead and label that positive pi over 4. And what's halfway between negative 5 pi over 4 and negative pi over 4? Well, that's going to be 3 pi over 4. Now, for cosecant, remember that the graph on the right goes up and the graph on the left side goes down. And there's my graph of y equals cosecant of x plus pi over 4. So here's a graph of cosecant that tends to be a little bit more challenging in the fact that I have a period change, a phase shift, and a vertical shift, plus a reflection due to the negative sign in front of my trig function. So here's what I'm going to have to do. For this problem, what you're going to want to do is distribute that pi over 4 into those parentheses. So really what this problem is going to look like is y equals 1 minus the cosecant of pi over 4x minus 3 pi over 4. Now the reason why you want to do that is because then you have everything within inside of your parentheses and you can set it to each one of your vertical asymptotes and solve for x. And that's what I'm going to do next. Take the pi over 4x minus 3 pi over 4 and set it equal to pi, 0, and negative pi. So hopefully you got some practice with turning those negative pi's and positive pi into 4 pi over 4 so that way you were working with common denominators. When you solved for x, you should get x to equal negative 1, x to equal 3, and x to equal 7. Now those are the locations of where my vertical asymptotes are going to occur. So I'm going to go ahead and plot those on my graph. So here's my negative 1. Make it a little bit more dotted. My positive 3 and my positive 7. I'm going to go ahead and label those. So negative 1, positive 3, and positive 7. Now I have a vertical shift of going up 1 unit. So remember how cosecant normally had horizontal asymptotes at 1 and negative 1? Well, now they're going to occur at 2 and at 0 because I shifted each one of those horizontal asymptotes up 1 unit. Now, again, that means that in this region, my cosecant graph is not going to occur. So remember, we need to find our halfway points. So what's halfway between 3 and 7? Hopefully you can recognize that halfway point as being a positive 5. And halfway between negative 1 and positive 3, hopefully you guys can see that as being positive 1. Now, normally, cosecant, remember, goes up on the right side and down on the left. But due to that negative being in front of my graph, it is going to flip-flop, and it's going to go up on the left and down on the right. And that is how you would handle this difficult looking cosecant equation. Here we have secant. And for secant, what you're going to do is the same process. You're going to take what is inside of those parentheses and set them each equal to the vertical asymptotes. So I'm going to take that 2x and set it equal to the negative pi over 2, positive pi over 2, and positive 3 pi over 2. In graphing this secant graph, you'll notice that I solved for x and got x to be negative pi over 4, x equal positive pi over 4, and x equal to 3 pi over 4. Now that is where I'm going to have my 3 vertical asymptotes. So I'm going to go ahead and plot those vertical asymptotes on my graph here. And label them accordingly. Now, just like with cosecant, my amplitude also defines where I'm going to have some horizontal asymptotes. So you can see that at 2 and at -2, I will have some horizontal asymptotes as well. The next thing, just like with cosecant, you have to find your halfway points. So we're going to look for what's halfway between -pi/4 and +pi/4, and that will be at 0. And halfway between pi/4 and 3pi/4 is going to be at pi/2. Now, secant is like negative cosecant, where this time we are going to rise on the left and fall on the right. And there's our graph of secant. So here's one last final example on graphing secant. Notice how I set up my amplitude to be 3 and -3. Remember that this negative out front means that we are going to be reflecting it. So secant typically rises to the left and falls to the right, so we're just going to flip-flop it at the end. But what we're going to do first is take what's inside of our parentheses and set it equal to our 3 vertical asymptotes of -pi/2, pi/2, and 3pi/2, and solve for x. Alright, so after taking what I have in the parentheses at x divided by 2 and setting it equal to each one of my vertical asymptotes for secant, I was able to solve for x and get x to equal -pi, +pi, and x to equal 3pi. Now those are my vertical asymptotes, so I'm going to go ahead and draw those in. And then labeling them accordingly as well. So -pi, pi, and 3pi. Now remember, with secant, where your amplitude is, you are going to have a horizontal asymptote as well. So I'm going to go ahead and draw those in. And then I just need to find halfway. So what's halfway between -pi and pi? That's going to be 0. And halfway between pi and 3pi is going to be at 2pi. Now, typically, secant rises to the left and falls to the right. But remember, because of that negative, it's going to be flip-flopped. So in this case, I'm actually going to fall to the left and rise to the right. Now that concludes our video on graphing secant and cosecant. If you have any further questions, we will address those in class on Monday. Have a great rest of your day.